Okay, good morning everyone. Today I'm going to explain Prism. So this is today topic is Prism. Okay, so do you know very well? So Prism means this is a shape of the prism. This is a shape of the prism. This is a vortex. This is a name is P. This is a Q. This is a R. This is a R. So prism is a transparent medium. Transparent medium. Prism is a transparent medium. So this is a air. This is a transparent medium. Transparent medium. This is air. This is also air. This is a made up of suppose a transparent glass, maybe water, maybe other material. So this is one type of okay. This is a medium. Transparent prism is a transparent medium. This is a medium. So this is air taken as another medium. This is a glass taken as another medium. So we have the two mediums. Prism is a transparent material separated by the surrounding medium by two planes. This is a one plane. So this is a PQ is a one plane. This is a QR. This is a PR. This is a planes. This is a plane. This is a QR. This is a base. QR is a base. PQ is a one plane surface, and the PR is a another plane surface of the prism. PQ is a one plane of the prism. PR is a another plane of the prism. QR is a base of the prism, base of the prism. So why we are going to study the prism? Why we are going to study the prism means we have to understand behavior of the light. But how can we learn behavior of the light? Means first the light falls on this is a PQ plane. This is a QR plane. QR. This is a PR plane. This is a QR is a base. We are calling base. So PQ and PR are planes, plane surfaces. So plane surfaces. PQ, PR are plane surfaces. Next to QR is a base surface. QR is a base surface. This is a base. We are calling base. This is a PQ, PR is a plane surfaces. QR is a base. QR is a base. So why we are studying this prism means so we understand the behavior of the light. So we are understanding the behavior of the light. So so we have to understand the behavior of the light. But how can we understand the behavior of the light? Means first of all, so light falls. This is a light ray. This is a light ray. This is a light ray. Light ray travels this direction and strikes on at this point. So this is a point we are taking. This is a M point. I'm taking this is a M point. I'm taking this is a M point. Okay, this is a M point. This is a light ray. Light ray travels this direction and strike at this point. We call this is a incident ray. So next, so we draw the this is a line. This is a straight line. Straight line is so we draw this straight line. This is a perpendicular to this plane surface at this at M point. This is we call normal line. We are calling this is a normal line. So this is we draw this is a straight line. We draw the straight line. This straight line is perpendicular to the PQ surface of the prism. We call this is a normal line. This is a light ray strike at this point, strike at PQ surface of M point. M is called as incident ray. This light ray strike at this point. This light ray is called as incident ray. So this is the angle between N and I. Angle between N and I. So we call this is angle of incident ray. incident ray. So light ray strikes at this point. We call that is incident ray. So light ray is this is air detection as a radar medium. This is a glass. This is a prism is made up of the glass. So this is a denser medium. Again, this is a radar medium. Radar medium. Light travels from. Do you know very well? Light travels from radar medium to denser. Light travels from radar medium to denser medium. Light travels from denser medium to radar medium. Light travels from radar medium to denser medium. So this is a light traveling towards this point and the actual direction of this one. So light, this is a light travels from radar medium to denser medium. So it is bending towards a normal. This is a normal light. This is an incident ray. This is a refractor ray. This is a angle of I. This is an angle of R. So light travels from denser medium to radar medium. This is a denser medium. This is a radar medium. This is a beam of light is traveling towards another medium. This is we call incident ray. This is the actual direction of incident ray, but this is a denser medium. This is a radar medium. Light entering into the second medium. It is moving away from the normal. This is we call angle of R. This is R. This is I. This is angle of I. Okay. So now, here you are seeing to the light travels from radar to denser. This is denser to radar. But deviation is equal to, what is the deviation here? Angle of I greater than 2 angle of R. But here angle of R greater than 2 angle of I. Here this is a deviation. What is the deviation? Deviation is equal to angle of I minus angle of R. This is a deviation is equal to angle of R minus angle of I. That is a formula. Okay, that is a basic point. Now, so you are seeing to this diagram, light travels from radar to denser medium. And light ray is refracted at M point. Light ray is refracted at M point. That light goes. This is a light travels from radar to denser means refracted bends towards a normal. This is a normal. It is bending towards a normal light. This is we call. This is a refracted R. This is a R1 I'm taking. This is the angle of R1. We call this is a refractor ray. R1 is refractor ray. But this is a normal line. This is a refractor. Angle between normal and refractor ray we call angle between N and R1 we call that is the angle of refractor. So this is a ray incident at this point. This is we call incident ray. This ray is refracted at M point. That ray moves through the glass prism and it reaches to reaching to the PR of the other surface of the prism. That is a point is N point. Light strikes this point, incident ray. Light ray refracted at M point. It moves through the glass prism. Moves through the prism and reaches to the other surface of the PR surface of the prism and strike at the end point. And so we draw the perpendicular to the surface, perpendicular to the PQ surface at the end point. So we are taking this is R1. So here we are taking. So for this one, this is a PQ surface. I1 is angle of incident, and PQ surface, this is a refractor. This is a PR surface. For PR surface, this is R1 takes as a incident ray. For incident ray, R2 is a incident ray. This is we call angle of incident ray. The ray is emergent at end point. At a point. Light travels from denser to radar. Light travels from denser medium to radar medium. Refractor rays bend away from the normal. This is a normal line. And refractor ray bend away from the normal line. This is we call emergent ray. This is I'm taking I2. This is I2 indicates emergent ray. Angle between normal and emergent ray. This is angle of emergent ray. We are calling. This is a term. This is a prism. That is a prism. You're seeing this is a, you're seeing to the prism. This is a prism. So prism is a transparent medium separated from surroundings, separated by them. Separated, separated. Prism is a transparent medium separated from surrounding mediums at least by at least two surfaces are inclined in a such a way that two inclined surfaces angle to each other, angle to each other. You see here clearly, this is a prism, this is a prism. You are seeing to the, this is a prism, this is a transparent matter. So why we are going to study this prism means, so we have to understand, we have to understand behavior of the light. So we have to understand the behavior of the light means, so immediately the light, when light falls on the PQ surface, this light ray strikes at this point. We are calling this is an incident ray, and draw the perpendicular PQ surface of the prism at M point. We call it become a normal at the M point. It becomes normal at this point. This is an incident ray. This is a normal ray. Angle between N and I, we call this is a angle of I1. We call this is a angle of incident ray. Next, light ray is refracted at M point. We are calling this is a refractor ray. R1 is refractor ray. We are calling R1 is refractor ray. So PQ surface, for PQ surface and PR surface. For PQ surface, this is a incident ray. This is a M point. This is a normal point. This is angle of I1. This is a refractor ray. This is R1. This is angle of R1 for this one. So this is a M point. This is a M point. This is a PQ surface of the prism. So incident rays, light rays strike at this point. We are calling incident ray. This light ray is refractor M point. This is a refractor R1. Angle between N and I, this is the angle of incident. So angle between N and R1, we call that is angle of refraction. For this surface. Light travels from radar to denser medium for this one. This is a normal line. This is a light travels from denser medium to radar medium. It is bending towards a normal. For this surface. Next, so this is a surface. What is a surface? This is a PQ surface of the. This is a PQ surface of the another surface of the prism. This is R1. R1 is R1. This is R1. This R1 refractor ray. It moves through the prism, and it reaches to the another surface of the prism, and reaching to the end point. This one R1 takes as this is R2. This is R1. For this one PQ surface of the prism, I is a incident, I1 is a incident, and R1 is a refractor for the PQ surface. I1 is incident ray for PQ surface. R1 is a refractor for the PQ surface. Angle of R1, angle of I1, angle of I1 for the PQ surface. Angle of R1 for this PQ surface. R1 takes as a R1 is a refractor ray for the PQ surface, but R1 is taken as incident for the PR surface. This is an incident. Draw the perpendicular to the PQ surface. Light travels from denser medium to radar medium. It is bending away from the normal. We are calling this is I2. I2 indicates emergent ray. This is angle between N and I2. We are calling this is angle of emergent ray. So you are see. Now you will see this is angular prism. This is angle of. So what is the meaning of the angular prism? Angle of prism means angle between PQ surface and PR surface. Angle of the prism. A indicates angle of the prism. Angle of prism. So what is the meaning of angle of prism? Angle of prism means angle between PQ and QR. That is the angle of prism. Angle of prism. Angle of prism means what is the angle of prism? Angle of prism. So angle of prism means what is the angle between A is angle between PQ and PR surface. PR surface. Yeah, surface. So A is angle between PQ surface and the PR surface. A is angle of prism. A is angle of prism. Angle of prism. Or this is angle of prism. Or A is called as refractive angle of prism. Angle of prism we are calling. Angle of prism. A is angle between PQ, comma PR surface. This is angle of A. Angle of A is called as angle of prism. A indicates angle of prism. A means refractive angle of prism. We are calling angle of refractive. Now this is a this is a relative terms. Or you are saying to the this is a relative terms. Next, so prism having two triangles bases. Prism having two triangles bases. Next other one is three rectangular plane lateral planes. Plane surfaces. So prism having two triangle bases, three rectangular planes. Angle between rectangular lateral planes. Rectangular lateral planes. So prism having two triangle bases, three rectangular lateral plane surfaces. Angle between rectangular lateral planes. That is a prism. So next year you are studying deviation. What is the meaning of deviation? So deviation means this is actual direction of incident. So this is a light ray strikes at this point. Light ray strike on the surface of the PQ plane of the prism. There is no prism means this light ray goes straight. This light ray goes straight. And this light ray goes straight. This is a light ray goes straight. There is no prism means this is a light ray goes straight. Next, this is a emergent ray. Emergent ray extend backward direction. This is a emergent ray. Emergent ray extends backward direction in dotted lines. This is the angle between here to here. This is angle between actual direction of incident ray and the emergent ray. We call this is a deviation. Angle of deviation del. It is denoted by the del. So this is angle of deviation. Angle of deviation means angle between angle between instant ray, instant ray, and instant ray and emergent ray, emergent emergent ray. So angle of deviation. It is denoted by the del letter or D letter or small d letter or capital D letter. Okay, you can take any one. So angle between incident ray and emergent ray is called as angle of deviation. Angle of deviation. We are calling angle of deviation. Angle of deviation. Okay, that is angle of deviation. So next, I'm going to explain derivation of prism. Derivation of prism. Okay, you are seeing today. This is a basic points of the prism. Basic points of the prism. Okay, so why we are going to study this one means so we have to understand the behavior of the light, So we have to study. So we have to understand the behavior of the light. How do we understand the behavior of the light means light should be falls on the top surface of the prism, one of the part of the surface of the prism. It is refractor at m point. It is passing into the prism and it is reaching to the another surface of the prism. It is the light emergent out from the another surface of the prism. You see that this is a direction of the incident ray. This is a refractor of the light, and this is an incident ray. Again, this is a emerging this light ray emergent from the other surface of the prism. This is a you are seeing to the light. You are seeing to the light. Okay, now you are seeing to the light. Here, so basic point is we have to understand that. So we have to study. We have to understand behavior of the light. You see this is a position of the incident ray. This is a position of the refractor ray. This is a position of the what is the position of this one? Emergent ray. This is emergent ray. This is a refractor ray. This is the incident ray. PQ part. I1 is a incident ray. I1 is a angle of incident ray. N is a normal, and this is a m at m on the PQ surface. This is R means refractor for the PQ surface. R1 is angle of refractor ray for the PQ surface. For PR surface, R2 is a incident ray for the PR surface. Angle of R2, angle of refractor ray for the PR surface. And N is normal. I2 is a emergent ray for the PR surface. Angle of it means we call that is angle of emergent ray. That is a PQ surface. QR we call that is a base of the prism. That is a basic points of the prism. And the prism having two triangle bases and the three rectangular lateral planes. Angle between the rectangular lateral planes. Angle of deviation means del or d, small d, capital D is any one letter you take any one letter. That letter is indicated the angle of deviation. Angle between incident ray and emergent ray is called as angle of deviation. We are calling angle of deviation. This is our basic points of the prism. Okay, next. Okay, next derivation of the prism. Okay, so derivation of the prism. We are seeing to the derivation of the prism. derivation of the prism. So here I'm going to explain derivation of the prism. So what is the incident ray in this topic? What is a incident ray? Incident ray, angle of incident ray, angle of incident ray, refractor ray, angle of refractor ray. Next, incident ray, emergent ray, angle of emergent ray, angle of the prism, angle of the prism, angle of deviation, angle of deviation. So we are going to see this one. Okay. Next, derivation of angle of prism. 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 Derivation of prism. Derivation of formula for refractive index of the prism. Refractive index of the refractive index of prism. Derivation of formula for refractive index of the prism. Refractive index of the prism. This is a title. So this is a very important. Very important. Very. Okay. Here, what I'm going to explain. You see, so in this prism, I'm taking to this is a prism. I'm taking to this is a prism. Prism. This is a point. This is a P. This is a point Q. This point taken as O point. So this is a light ray incident at this point. This is a we are taking M point. So light ray incident at this point we are calling this is incident ray. So we draw the perpendicular to the PQ surface at the M point. We call this is a normal line. So angle between I and N means this is the angle of I1. We call angle of I. This light ray is refracted at the M point. Light travels from this is N1. I'm taking this is N1 is equal to 1. This is a refractive index of air is taken as 1. This is a refractive index of the glass is taken as N. This is air means we are taking the air is taken as radar medium. This is a glass medium. Glass medium is taken as a denser medium. Denser medium. Light travels from radar to denser means refracted ray bends towards the normal. This is a refracted ray. This is what we call angle of R1. Angle of R1. We are calling this is angle of R. Angle of R. Angle of R1. This is M point. M point. M point. So that is the M point. So next for this surface, PR surface, this is draw the perpendicular. This is a point is N point. Light travels from denser to radar means again light ray is bending this direction. this direction. We are calling this is I2. This is a I2. Angle between N and I2 means that is angle of I2. Angle of I2. Angle of I2. Angle of angle of. So this is N1 is equal to this is a refractive index of A is equal to 1. This is a refractive index of A. So this is a refractive index of the glasses. Yeah. And for this one, this is R2 I'm taking. This is angle of R2. Angle of R2. This is a P point. This is angle of prism. We are calling this is angle of A. Angle of A. At this point. So this is instantly extend in a this there is no prism means this light goes straight. So this emergent ray can extend backward direction in dotted lines, and this is a point is from here. This is an angle. What we call this angle? That is angle of deviation. Angle of deviation. Angle of deviation. That is. Now angle of deviation. That is the angle of deviation. You see that? So we are finding the deviation. For this one, deviation from triangle. From triangle. This is I'm taking O M N. This is an N point. This is a M point. M point. From this triangle, what I'm taking here. So I have to take triangle. Deviation is equal to deviation. Deviation is equal to what is the deviation? So for PQ surface, light travels from rarer to denser, rarer to denser. The PQ surface. We know one thing here. Light travels from rarer to denser. Rarer to denser means so what happened? This is incident ray. This is actual direction of incident ray. This is a refracted ray. Deviation is equal to here angle of I minus angle of R. Next, light travels from denser medium to rarer medium. Denser medium to rarer medium. So this is a light ray. This is actual direction of light ray. So this is a refractor ray. That is R2. This is I. Okay, R2I. Okay, you take the deviation is equal to angle of R minus angle of I. So light travels from denser medium to rarer medium means this is a deviation. Light travels from rarer to denser means this is a deviation. This is a PQ part. This is a PQ surface, and this is a PR surface. Total deviation is equal to and angle of I minus angle of R plus angle of R minus angle of I. But what is the deviation for this one? This is I1. This is R1. For this one, I2. This is we are taking the emergent ray. We are taking that is R2, I2, R2, I2. So we are taking this is the angle of R, but letter is this is I2. We are taking letter is I2. This is the letter is R2. We are taking. Okay, term switch. Deviation is equal to angle of I1 plus angle of I2 minus take the common angle of R1 plus angle of R2. Angle of R. So that is the deviation is equal to I1 plus I2 minus R1 plus R2. But this is angle of incident ray. But I'm just remove the angles. Okay, but I1 indicates angle of incident. I2 indicates angle of emergent. R1 indicates angle of refractor ray. R2 indicates angle of refractor. Okay, keep in your mind. Okay, here this is deviation. Next, triangle. So PM, not a PMN. PQR from triangle PQR from the triangle. It's angle of A plus here is angle. So here from here to here is angle is from here to here is This is from here to here is 90 degrees. This is a 90 degrees. From here to here is 90. 90 minus this one is, this is remove that one. 90 minus R1. That is 90 minus R1 plus for this corner. So this is from here to here is from here to here is 90. 90 minus R2. 90 minus R2 is equal to total value is 180 degrees. 180 degrees. So 90, 90, 180 and 180 cancel each other. Angle of A minus common R plus angle of R2 is equal to, okay, angle of A R1 minus R2. R1 plus angle of R2 is equal to, okay, 0 is equal to 0. So this is A is equal to, we are going to write this is angle of R1 plus angle of R2. Okay, this is we are taking R1 plus R2. This is equation number 2. Equation number 2. This is we are taking equation number 1. This is taken as equation number 1. This is taken as equation number 2. Equation number 2. Okay. So next, this is the formulas we have, and next. Snell's law applies point M and point N. So Snell's law apply at M point. At a M point. Snell's law is, what is the Snell's law? N1 sine I is equal to N2 sine R. This is we have the Snell's law. N1 means, what is the N1? N1 is equal to 1. N1 is equal to 1. N2 is equal to refractive index of the material glass, and I is equal to, what is I1. So what is next? R is equal to, we are taking R1. This all values put in this equation. N1 means 1, sine I means I1 is equal to N means N, sine R means R1. So we are going to here N is equal to sine I by sine R. Sine I by sine R1. This is refractive index of the material. Refractive index of the material we are taking. We are taking. Okay, next. See here, Snell's law applies. Snell's law applies. Apply at N point. N point. Snell's law applies. This is a point. For that one, same Snell's law, N1 sine I is equal to N2 sine R. So N1 means, what is the N1? Light travels from denser medium to radar. This is we are taking N, refractive index of the material glass. I'm taking N. N2 is equal to 1. Next to I1 is equal to, we are taking R2. Next to R is equal to, we are taking I2. We are taking I2. All values put in this equation. N sine I means R2. This is N means, N2 means 1. Sine R means I2. We are taking. So N is equal to, this is a sine R2 I2 by sine R2. Sine R2 we are taking. R2 we are taking. This is refractive index of the material. Refractive index of the prism. Refractive index of the prism. Now next, so at angle, so this is a minimum angle of deviation. Minimum angle of deviation. So here, this is I1, this is I2. So here I am taking the I1 is equal to 30 degrees, 30, and I1 is equal to 30 degrees, 40 degrees, 45 degrees, 60, 65, 60, 70, 80. I am increasing the, so angle of incident increases. Angle of emergent ray also goes on increases, and goes on decreases. Again it goes on increases. So here I am, this is angle of incident ray goes on increases. Angle of deviation also goes on decreases. Angle of incident ray increases. Angle of emergent ray goes on decreases. Angle of incident ray increases, and angle of incident ray, angle of emergent ray, both are same at one angle. That is we call minimum deviation. Angle of minimum deviation. Angle of minimum deviation. Deviation. The time angle of I1 is equal to angle of I2. We are getting minimum angle deviation. So this is angle of I is equal to angle of forward. Here angle is equal to here. This is I1 means angle of incident ray. I2 means angle of emergent ray. Angle of emergent ray. Both are equal. The time we are getting. What will happen means here. So this is a prism. This refractor ray. This is a refractor. This is a refractor ray. This is a P and Q. This is R. P, Q, R. This is a refractor. Both are parallel to each other. In this condition, and refractor ray is parallel to the QR baseline. Base of QR line. QR base of the QR. QR is the base of the prism. In this situation, the situation how can we get means angle of I1 is equal to 30 degrees, 35 degrees, 40, 45, 60, 70, 80, 90, until up to exactly we are not taken to the 90 degrees. So this is angle of incident goes on increases. Angle of emergent ray goes on decreases. One particular angle of incident ray is equal to angle of emergent ray. Both are equal. That situation we are getting minimum angle of deviation. Angle of deviation is minimum angle of deviation we are getting. Minimum angle of deviation we are getting the time. Okay. So angle of I1 is equal to I2. Okay, this value is put in this equation. What we are getting, deviation is equal to. So what is the deviation? I1 plus I2 minus R1 plus R2. Okay, this is a we have the equation. So what is the equation? Equation. This is equation number 1. This is equation number 2, and this is we have the two equations in this two equation. Okay, this is deviation is equal to I1 plus I2 minus A. We are putting this equation A. Okay, this is we are checking. Okay, this is equation you are seeing here. In this situation, deviation is equal to I1 plus I2. This is a minus R1 plus R2 means that is A minus A. So that is D. Take this side A means plus. This is I1 plus I2. This is equation number 3. Equation number 3. Equation number 1. Equation number 2. Equation number 3. Equations. Here we have the three equations. What we have, you see that one. We have the three equations. One is what is the one is equation. So this is the equation. D is equal to I1 plus I2 minus R1 plus R2. This is a D is equal to I1 plus I2 minus this is a R1 plus R2 means we are writing A. This A take this side. D plus A is equal to I1 plus I2. That is this equation is taken as equation number 3. Equation number 3. This is equation number 3. And Snell's law applies. This is a Snell's law. So where is a Snell's law? Snell's law applies. Snell's law apply at M point. So light travels from radar medium to denser medium. I1 you are taking I1. R is equal to we are taking R1. So what is a Snell's law? Snell's law is N1 sin I is equal to N2 sin R. N1 means 1. Sin I means what is I1 is equal to N2 means N. We are taking N sin R means R1. N is equal to finally sin I by sin I1 by sin R1. This is a Snell's law formula. This is a refractive index of the prism. okay, in this condition, minimum angle of deviation. Minimum deviation, we are getting minimum deviation. This is a minimum deviation we are getting when we are getting I1 is equal to I2. Okay, this is a D plus A is equal to, here I1 is equal to I2. I1 plus I2 means I2 is equal to I1. This is a D plus A is equal to, we are taking 2I1. This is I1 is equal to what we are going to write. This is D plus A by 2. D plus A by 2. This is I1. This is I1. So so in the minimum deviation, we are getting R1 is equal to R2 also. R1 is equal to R2 also. So this is angle of prism is equal to R1 plus R2. R1 plus R2. A is equal to R1 plus R1 is equal to R2 means R1 is equal to R2. R2 means we are taking R1. Here A is equal to 2R1. R1 is equal to A by 2. This is we are taking. This is a, so we got I1 value, R1 values. These two values put in this equation. Any Snell's law. This values put in this equation. This is a values. I got I1 value. I1 is equal to D plus A by 2. Next R1 is equal to A by 2. I got this value. So these two values put in this equation, I'm getting the refractivity of the prism. This is the two values. Okay. Okay. So next, okay. This is the situation and the deviation. So we got n is equal to sine I1 by sine R1. I know values sine I1. What is the I1 value? I1 value is I got D plus A by 2. D plus A by 2. This is a value by sine R1. Sine R1 means what is the R1 value? A by 2 I got. This is a refractive index of the prism. Refractive index of the prism. It is a derivation is over. Derivation is over. In some other way, we have to do this one some other way. How can we do this some other way? You see, situation. So we have actually D is equal to I1 plus I2 minus, this is a A. Okay. This is in the equation number 3, D plus A is equal to I1 plus I2 from equation number 3. So we have the condition I1 is equal to I2. From this condition, D plus A is equal to, this is I1 is taken as I2 plus I2. This is D plus A is equal to 2A. This is D plus A is equal to, we are taking, this is a 2I2. I2 is equal to D plus A by 2. D plus A by 2 we are taking. Next condition R1 plus R2 is equal to, this is angle of prism. We have the condition in the angle of deviation condition R1 is equal to R2. R1 plus, this is R2. This is A is equal to 2R2. This is R2 is equal to A by 2. A by 2 we are taking. A by 2 we are taking. So we have the Snell's law. N is equal to, what is the Snell's law? Sine I2 by sine R. Sine R. R2. This is N is equal to sine I2. I2 means, what is I2? I2 means D plus A by 2 by sine R. Sine R. Sine R means, what is R? This is A by 2. A by 2. This is a refractive index of the prism. Refractive, that is a refractive. N indicates the refractive index of the prism. So we have to done these two methods. The two methods. This is the angle of the prism. Angle of prism. This is N indicates. This is N indicates. This N indicates refractive index of the prism. Refractive index of the prism. Refractive index of prism. This is a prism. Refractive index of the prism we are finding. This is a derivation of. This is a derivation of derivation of a formula for differential extras of Prism. This is a derivation. It is forward. Okay, so this is a very important for my dear students. This is a very important for the exam. Okay, so this is a derivation. Okay, this work as over. Okay, tomorrow I will explain. Thank you. Thank you very much. You know.
లీవ్ చేయాలి అంతే కదా ఇది అంతే